Hello guys, welcome back everyone. So this is the extension class of the previous class. In the previous class, we learned how for loops work, how to use the range function, and how to iterate through strings and nested loops. So in this class, we are going to learn loop control statements like break, continue, pass, the else clause with loops, memory efficiency of range function, string operations using loops, multi-dimensional nested loops, and we will also discuss about some common mistakes that beginners will do. So let's learn each topic one by one. First, loop control statements. Loop control statements. So sometimes we don't want a loop to run completely, right? Sometimes we want to stop the loop immediately or skip one iteration or leave a placeholder for future code. So Python provides three special statements for these, which are break, continue, and pass. Let's discuss one by one. What is break? The break statement immediately stops the loop. The break statement will immediately stops the loops. The moment Python encounters the break, it exits the loop and starts executing the code after the loop. The moment Python encounters the break, it exits the loop and start executing the code after the loop. So think of it like this. Imagine you're searching for your notebook in a stack of books. As soon as you find it, did you continue searching? No, right? So you stop immediately. This is exactly what break does. First, we'll learn about syntax. The break syntax is so this is the syntax of the break. Let us see an example for this. For example, I want to loop over numbers in the range of 1 to 10, but I don't want to print the numbers after 5. So this is the condition. Now we'll write logic for this. Okay. So what happened here? Here I have taken a for loop, and here the number is the variable which will shows the output 1, 2, 3, 4, 5. So here I have written a condition that if number double equal to 6, then break. So what will be the execution of the Python will do? In the iteration 1, the number will be equal to 1. In the iteration 1, the number equal to 1. So it will check the condition like is 1 double equal to 5? No, no, right? Then it will directly prints the number which is equal to 1. So the output is 1. And next it will check 2 for 2. Is 2 double equal to 5? No. And then 3 and then 4 and up to 5. Oh, sorry. And up to 6. It will check is number double equal to 6. And then when the number is holding a value of 6, it checks the condition if number double equal to 6, which means 6 double equal to 6, which is true, then it will execute break. The break statement will automatically stops the next iterations. So it will automatically stops the next iterations of 6, 7, 8, 9. Okay. And next, uh, I'll take a real world example. Suppose you are searching for a student named Rahul in the attendance book. So the teacher will search from first step to last, from first student to the last student, right? So like student 1, student 2, student 3. If Rahul is in student 5, then the teacher will automatically stop searching for the next records. So this is what exactly happens in the break statement also. Next, continue statement. So what is continue? Unlike break, continue does not stop the loop. Unlike break, the continue does not stop the loop, and instead it skips only the current iteration and moves to the next one. Think of it like this: you are checking answer sheets. Whenever you find a blank page, you skip it and continue checking the next page, and you don't stop checking all papers, right? This is what happened. Let's see the syntax of the continue. So this is the syntax of the continue statement. For item in sequence, we use an for loop to iterate over the range of numbers or a sequence, and here we are checking a condition. In that condition, if the condition met particular statements, then it will continue, which means it will skip an iteration and then continue to the next step. Let's see an example for this. So you guys can guess what will be the output. The output is 135. Why? Why is the output only 135? Because here I have written a condition that if number percentile 2 double equal to 0, then continue, which means it will skips every iteration of the even number. Every iteration of the even number. It will checks like if, for example, in the first iteration, the number will be 1, right? Then it will check is 1 percentile 2 double equal to 0. Is 1 gives a remainder of 0? No, right? Then it will print 1. It will, which means the 1 is an odd number. So it is printed as 1. And in the second iteration, it will check is 2 percentile 2 double equal to 0. Yes, it is true. 2 divisible by 2 gives a remainder of 0. So that's why it is skipping and going to the next iteration 3. And in the third iteration, it checks like the above. Is 3 percentile 2 double equal to 0? No, because 3 is an odd number which will give a remainder of 1 which is not equal to 0, then it will print of number which is 3. So this is the workflow of above program. I hope you guys are understanding. Next, one real life example of continuous statement is, imagine a teacher checking homework. Students like A, B, C, D. Student B forgot the notebook. Then teacher will skip the student B and checks the student C and student D. So this is the example of the continuous statement, small example. Next. So we have learned about break and continue, right? Can you tell me the difference between these two? The difference between break and continue. Break stops the entire loop, while the continue skips only one iteration. Break loop ends immediately. In the continue, loop continues normally. Break used when work is finished. And continue used when one item should be ignored. So this is the key differences between break and continue. Next, pass statement. What is pass? Sometimes Python executes a statement, but you don't want to write any code yet. In such situations, we use pass. It does absolutely nothing. It is simply a placeholder. Pass means placeholder. This is the easy trick to remember. Pass means placeholder. So, first we'll see an example program. So, the syntax of the pass means in the place of continue, we just replace it with pass. This is the syntax of the pass. And the code is also the same. So let's take the before example only. This is the example of the pass. So what happened in this code? In the for loop, the number will become 1 in the first iteration, and it checks the condition if number percentile 2 double equal to 0 means is 1 percentile 2 double equal to 0. No, right? So in the condition, we have written that pass, which will do nothing. So it done nothing. And next it will directly print number which is 1. And next the above process is repeated up to 5. Is 2 it checks that is 2 percentile 2 double equal to 0 and pass. Here it only checks a number is percentile 2 and returns nothing, just printing a number. So instead of writing these, we can write these two, just print a number. It will also give the same output. But I just want to show you the use of the pass statement. Okay, next. Why use pass? In what situations we use pass? Suppose you're planning your program but haven't written the logic yet. Instead of leaving an empty block which causes an error, you can write pass. Later, you can replace pass with actual code like the process I have shown you. In the place of pass, you can print anything or you can write anything that you wanted to do later. So, pass means simply a placeholder that holds nothing. Next, the else clause in for loops. Many programming languages don't have this feature, right? So Python allows us to write else clause for the for loop. The else block executes only if the loop finishes normally. The else block will be executed only if the loop finishes normally. If the loop stops because of break, the else block is skipped. If the loop uh, s- stops because of break, the else block is skipped. So let's see an example for this. Printing a prime number. For example, here I have taken a number that is equal to 7 and checking that it is prime or not by using for loop. So what is the condition for the prime numbers? What is mean by prime number first? A prime number means a number which is divisible by itself and 1, right? That is a prime number. Okay. This is the code to check a number is prime number or not. So first let's see the flow of execution. First, the number is equal to 7. In the first for loop, the I will become 2 because the start number is 2. So I equal to 2 and we are having number equal to 7. What is the condition? The condition tells that number which is 7 percentile of I which is 2 double equal to 0. What is this condition? This condition is just like the checking of even numbers, right? Is 7 percentile to double equal to 0? Which means is 7 gives a remainder of 0? No. So this block will be never executed. Next, it will check next number which is 3. Is 7 percentile 3 double equal to 0? Is 7 percentile 3 double equal to 0? No, 7 is not divisible by 3. And next it will checks by 4. By 4 also 7 not divisible by 3, 7 not divisible by 4 and by 5 also. 7 is not divisible by 5, by 6 also it is not divisible and the loop ends after 6, the loop will ends automatically because here we are saying up to num, which means num minus 1 that equal to 6. The output will be what? Prime number. Prime. Oh, because the else clause is written inside the loop. For that case, it is printing prime number for the multiple times. Instead of writing else in the for loop, we can write the else block outside of the for loop. You can see prime. So this is the next concept. The else clause for loops. Next, memory efficiency of range. Many beginners think range of 1 lakh creates 1 lakh numbers or range of 1 million will create 1 million of numbers. Actually, it doesn't. Python is smarter, right? Instead of storing everything of like 1 million records, it stores only start, stop, step. Whenever the loop asks for the next iteration, Python generates only that number. This saves a lot of memory. Like, for example, the range of 1 to 1 million will does not create 1, 2, 3, 4 up to like up to 1 million will does not create 1, 2, 3, 4 up to 1 million in the at the same time. Instead, it generates 1, next 2, and next 3 and 4. So this is the workflow of the range function. Why is this important? Because it allows Python to handle very large range efficiently without using exclusive RAM. It allows Python to handle very large ranges efficiently without using excessive RAM. Next, total iterations formula. We should must learn total iterations formula. When the step value moves towards the stop value, the number of iterations is total iterations equal to CEIL, which is seal function. Seal of stop minus start by step. This is the formula. So this helps estimate how many times the loop will execute. How many times that the loop will be executed. So this is the formula of the total iterations. You can see this is the formula. Next, string operations with loops. First one, string operations with loops. So loops are very useful when working with text. String reversal, accumulator pattern. We see the string reversal accumulator pattern. String reversal. We are seeing this concept accumulator pattern string reversal. Okay, let's see an example. For example, I want to reverse a variable, name called Ravi to IVAR. How can I do that? By using the string reversal method. So let's see this step by step by writing the code. So first see the workflow. How can Ravi will become IVAR? How should it become IVAR? First, we should store the Ravi in a variable called original. Original equal to string Ravi. And next, we should store the reversal name in the another variable like reversal equal to, we should store string, right? So that's why I'm assigning double quotes, single quotes. Now in the first iteration, in the reversing program, we must and should use loops. In the first iteration, we'll have R. So the new string will be R, right? And in the second iteration, we are having A. Now the new string will be AR. In the third iteration, we are having V. So the new string will be V and we are having AR. And in the fourth iteration, we are having I. Here the new string is I and the old string is var. So this is the workflow of reversing a string. Reversing a string. Now let's see code step by step. First, we should take a variable called original. In that I'm taking hello, and I'm taking another variable reversed string to store the variable reversed string. Now I'm using for loop to iterate over the string for char in original. So here what is the logic to reverse that? Reversed str equal to what? Char plus reversed str, which will be in the form of, I have already shown you, right? It will be like first R, then AR, and then VAR. So it will store the string like this. After execution of loop one, it step by step, it will store like this, and the final output will be stored in reversed str. Next, we will print it. Oh, what happened here? Why it is not printing anything? So what happened here is the variable name is wrong. REVERSCD. So it is taking some time due to network issue. Okay, this is the output. So in Python, variable name matters more. Please don't do mistakes like me. Next, enumerate. Enumerate means sometimes we need both character and position. Instead of manually maintaining a counter, Python provides enumerate. So enumerate will give index and the character at the same time. We will see code. I'm taking a variable text and assigning a value, a string code. I'm taking a loop in that to print the index and the character at the same time. I have taken two variables, index and char, and I'm using the predefined function that is provided by the Python, that is enumerate. Enumerate of text, and I'm just printing both index and char. Okay, this is the output. This is the use of enumerate to print the index and char at the same time. And next, multi-dimensional nested loops. Okay, nested loops can have 2 levels, 3 levels, or more than 3 levels. Like for x in range of 2, for y in range of 2, and Yeah, wait. But in range of 2, print of x, y, z. Hmm, this is the nested for loops and also multi-dimensional nested loops. Why are these used? To represent the 3D graphics, to represent cube coordinates, RGB image processing, scientific simulations, game development. This is the use of multi-dimensional nested loops. Okay, and we'll see some common mistakes. The common mistakes that beginners will do is modifying a list while iterating. Do not do that. This can cause elements to be skipped because the list changes while the loop is reading it. Because the list is changed while loop is reading it. Next, variable shadowing. Avoid using names that are already used by Python's built-in functions. Okay, so today we learned several advanced topic concepts like break, continue, pass, else clause, and enumerator, accumulator, multidimensional nested loops. Practice these concepts by using several other programs like print numbers from 1 to 20 but stop the loop when the number is 50. Print all numbers from 1 to 20 skipping the multiple of 3. Write a program that reverses your name using the accumulator pattern. Okay, I hope you guys liked the video. Thank you. That's it for today.